Hello, I am Flash Isaac. This is Flashlearners. You are now watching more than 20 Days to Jamb, a series containing 120 episodes which covers all the topics in Jamb syllabus. Each episode comprises detailed class, questions, and homework. The questions and homework are from the Flashlearners Jamb application. This makes the app a requirement for this class. Visit Google Play Store or flashlearners.com to get the app. Do you have trust issue? Reach me on any of my social handles for activation guide or enquiries. Ladies and gentlemen, it is time to take off. This is episode number 15 of the 120 Days to Jamb Physics with Flash Isaac. In this episode, we shall be looking at the topic motion, excluding calculations under linear motion, because in episode 2, 3, 4, and 5 we dealt with a lot of calculations under linear motion. Let us begin this way. What is motion? Motion is change in position of an object with respect to time. Why not? Things, events happen with respect to time. For example, velocity is change in displacement with time, or rate of change of displacement. Anytime you see rate in physics, it speaks of time. We can therefore say that motion is the rate of change in position. If you are here, point A, and you move to point B, this is your first position and this is your second position. In the process of moving from A to B, time is spent. And what is the cause of motion? Force is the reason for motion. It is the agent that tends to stop the object that is moving, or that tends to make objects to move, and force also makes objects to change direction. The top types of motion are translational motion. This is the motion of a body or of an object in a fixed direction. In this motion, the object moves from point A to point B. This is a translational motion. Example, the motion of a car. If you are driving from town A to town B in a fixed direction, you are exhibiting a translational motion. Oscillatory motion is to and fro motion of a body. We can say the simple pendulum, even heartbeat should be gbing, gbing, gbing. That should be an oscillatory motion. Another type of motion we have is rotational motion. Rotational motion is the motion of a body or of an object about an axis or about its own axis. Look at it. If you have an axis here and something is plugged here and it's moving about that axis, we say that is rotational motion. Look at your car tire. You have something like this, then the tire is here. As you drive, this is the axis. The tire is rolling about that axis. That is rotational motion. Or you have something like this. Ceiling fan. Now, you see here now, this is the point. Your ceiling fan, this head of the ceiling fan is rotating about this point. So any motion where an object or a body is rotating about an axis is referred to as rotational motion. There is a big discrepancy, disparity, dichotomy, difference between rotational motion and circular motion. Rotational motion is the movement of a body about a fixed point. Meanwhile, in circular motion, we have a fixed point while this body moves around it. For example, roundabout. In a roundabout, this is a fixed point. Then a car is going around that fixed point. So the axis is not moving, it's a fixed point, while the object is the one moving around it. That is an example of circular motion. Now, in the ceiling fan, the movement of the fan about its axis is rotational motion. But the movement of the fan blade about this axis is circular motion because here is fixed while the fan blades are moving around it. And these are things you should note about circular motion. One, circular motion, the point is fixed. The body moves about a fixed point. Looking at another example, you have the sun, which is fixed, and the earth is moving about it in a circular manner. The point is fixed, and the speed in circular motion is constant. Speed is constant, but direction is constantly changing. So the body is constantly changing direction. Then the velocity, acceleration, and momentum are constantly changing. Meanwhile, the velocity is directed along the tangent. When you are given this circle here, this is the tangent. So the velocity is directed along that tangent. And the acceleration is towards the center. So what are the characteristics of circular motion? It's a motion of a body about a fixed point with constant speed, then constant direction. The direction is changing constantly. The velocity, acceleration, and momentum are constantly changing. Meanwhile, the velocity is directed along the axis, along the tangent, while the acceleration is towards the center. We have random motion. This is the movement of a body in zigzag manner. The motion of the butterfly, smoke, all these they exhibit random motion. Even gas, the motion of gas molecules are random and they collide with themselves and the wall of the containing vessel. Therefore, gases possess kinetic energy and the collision in gas molecules is elastic because momentum is conserved and no energy is lost. Energy before collision is equals energy after collision. And relative motion is the motion of one body relative to the other. In one of the episodes, which was the last episode, we talked about relative motion and we solved the question under relative motion. What is an example of relative motion? As you are traveling or you are driving, the motion of the trees and the pole, they are relative to you. So the motion of one body in relation to another body, that is relative motion. If a body moves in horizontal manner, its force acts on it. Gravity also acts on the body. Gravity is a force that brings all objects down, which means anything that goes up will surely come down. It is as a result of the force of gravity bringing all objects back to the ground. Now, there is a situation where a body is moving vertically upward like this. If you are going up, you are against gravity. If you are coming down, gravity is favoring you. When a body is launched vertically upward, we say that the motion of that body is motion under gravity. And what happens in motion under gravity? Before we get there, let's take a look at Newton's law of motion. There are 3 laws of motion, although people say that there is a 4th law which states that when people are mad, they tend to move faster. Is that true? Yes. So let's look at Newton's 3 laws of motion. The first law is referred to as the law of inertia. It states that a body at rest will continue to be at rest. A body in motion will continue in that state of uniform motion in a straight line unless it is acted upon by a force, which means force causes motion, force causes change in direction of objects of motion, force can stop motion. And what is inertia? Inertia is the reluctance, unwillingness of an object to move if it's already resting, or to stop moving if it is already moving. If you are sleeping, you are at rest. To wake up is problem. That is unwillingness to wake up. Then if you are running or you are moving or you are walking, you don't want to stop unless something stops you. So that unwillingness to move or to stop moving is referred to as inertia, and it's due to mass of a body. That's why you also have inertial mass. And the second law of motion, which is so important, states that the rate of change of momentum of a body is proportional to the force applied, and it takes place in the direction of the force. What is momentum? Momentum of any body is the product of its mass and velocity. Momentum is mass times velocity. You look at a very heavy trailer. A very heavy trailer, if it hits this wall with a particular speed, and a child 10 years old hits the wall with the same velocity, you will notice that the trailer will cause more damage than the boy. Why? It has more momentum. Mass times velocity. So as you are moving, your mass and the velocity at which you are moving, they multiply to give momentum. But the change in momentum of a body is proportional to the force applied. What is change in momentum? Change means final minus initial momentum. What is final momentum? Final momentum is mass times final velocity. What is initial momentum? Mass times initial velocity. Therefore, change in momentum is equals mass times final velocity minus mass times initial velocity. This is change in momentum. Now, it says the rate of change in momentum. Rate of change in momentum is simply change in momentum over time. Newton is trying to tell us that this change in momentum over time is proportional to force. And if you take the constant to be equals 1, we will have that force is equals mv minus mu over time. And when you factorize, bring out 1m, you have mv minus u all over time. This is second law of motion. Now, from this law, if you are very smart, you see something. If F is equals mv minus u over time, v minus u over time, this is change in velocity over time. And what is change in velocity over time? Change in velocity over time is acceleration. Therefore, force is equals mass times acceleration. And the third law of motion states that for every action, there is an equal or opposite reaction. If I hit this board, I'll have a reaction that is equal to the force I am applying. If you shoot a gun, boom, for every bullet going out, you are getting opposite reaction. This is why some persons or some children or people who are not very strong should not shoot gun, because as you shoot, boom, you see, opposite reaction. That is the third law. And you get to conservation of momentum. You have elastic collision, because collision occur when two bodies come in contact. If after contact the bodies remain, they bounce back, no harm, we say it is elastic, which means momentum before collision is equals after collision, and energy is conserved. Now, from the three laws of motion, or from the laws of motion, we are able to arrive at three equations of motion. The first one is V is equals U plus AT. The second one is S is equals UT plus 1 over 2 AT squared. The third is V squared is equals U squared plus 2AS, where V is final velocity, U is initial velocity, S is equals distance, T is equals time, and A is equals acceleration. These are the equations of linear motion. A question now comes to mind. What if the motion is under gravity? Which means, what if the body is going up or down? What happens? If the body is going up, we know that G, acceleration will be negative. Why? Gravity is acting on the body. So which means instead of plus here, we'll use minus, since it's acting against gravity. When the body is going up, against gravity, acceleration is negative. And when a body is going up, Is it this acceleration? No. A is linear acceleration. A body against gravity will have acceleration due to gravity. In that case, the acceleration is g, not a. Rewriting this for motion under gravity, you simply have that v is equals u minus, because it's against gravity, g, a becomes g, gt for motion under gravity. Then distance becomes height. S is horizontal distance. Vertical distance is height. As you are going up, you are covering a height. So h is equals ut minus, because it is against gravity, 1 over 2 g t squared. A becomes g. Then v squared is equals u squared plus 2gh, because distance becomes height. So these are equations for linear motion, and we've used them to solve a lot of questions in episodes 2, 3, 4, and 5. Now these are equations for motion under gravity. Now, looking at velocity and displacement or acceleration. You see a body like this accelerates uniformly, covers a distance or velocity, then decelerates. For this type of motion, the total distance covered is area under the shape. So you can do it this way. Here, let's say acceleration is equal to 2 meters per second. Then let's give you velocity 20 meters. Then here is time 2 seconds, 5, 0, and 6. From here, you'll be able to find distance or whatever you are asked to look for. In the next 2 episodes, we shall be solving questions. So you will see the application of this. This episode is basically to introduce everything, give you the formulas you need. In the next 2 episodes, we'll be solving questions, hot questions. Now, projectile. We've looked at inertia, mass, and force. And we've been able to get that force is equals mass times acceleration. And impulse is change in momentum. If this is mv minus u over t, like we established earlier, when you cross multiply, you have ft is equals mv minus u. Now you agree with me that here is mv minus mu, which is change in momentum. Change in momentum is impulse. So ft is impulse, and it is change in momentum. Then projectiles. Projectiles are body launched and allowed to fall freely under gravity. Look at this. If you have this, examples of projectiles are arrow, gun, ball, catapult, launched. Once you launch this body and it gets to maximum height, and you allow it to fall freely under gravity, we say this is a projectile. It starts from here and it ends here. So this beginning to the end is referred to as the range. And here is the maximum height. The path taken by a projectile motion is referred to as trajectory. That is the path the projectile motion take. And in projectile motion, you'll be required to calculate time taken to get to the maximum height. The time it takes to get to maximum height is u sin theta over g. And what is time of flight? Time of flight is the time it takes to go up and the time it takes to come down. If the time it takes to go up is equals the time it takes to come down, neglecting air resistance, and take note that the only force acting on projectile is the force of gravity. Air resistance is neglected. So time of flight is 2 times the time taken to get to the maximum height. Because if it takes 2 seconds to go up, it will take 2 seconds to come back. Total time is 2 times 2, that is 4, which makes the time of light to be 2u sin theta over g. Time of light, time to go up, time to come down, 2u sin theta over g. Then the maximum height is u squared sin squared theta over 2g. And the range is from here to here is u squared sin 2 theta over g. Now, the range is maximum when theta is 45 degrees. Why? If theta is 45 degrees, 2 times theta, that is 90 degrees, and sin 90 degrees is 1. So, if you are told that the range is maximum, arrow mass is u squared over g. No need to look for the angle. And I've talked about motion in a circle. Now, simple harmonic motion. Simple harmonic motion is an oscillatory or vibratory motion of a body from a fixed point whose acceleration is always directed towards that fixed point. If you have this mass on a spring or simple pendulum, once you push this, it goes here and comes back. It goes here and comes back. So the acceleration is directly proportional to the displacement towards this fixed point. And the reason for simple harmonic motion is restoring force, because as this body goes, it is the restoring force that brings it back, goes, it comes back. So restoring force is the reason for simple harmonic motion. Ladies and gentlemen, with this, we've come to the end of this episode. We've introduced everything we need to do in the next 2 episodes. In episode 16, 17, we shall be solving hot cake questions under simple harmonic motion, projectile motion, Newton's laws, random motion, motion under gravity, and types of motion. And I hope you found this helpful. For the next 2 classes, I highly recommend that you install and activate the Flashlearners Jamb applications, because you need them more than ever. That is it. Take care of yourself.